Hmm. Can somebody confirm that you can hear me?
We can hear.
Yeah.
Great. Oh, didn't make it in time. All right. Are there any questions before we begin? I posted an announcement. Maybe I can show that. That I was delayed last Monday, so I was not able to meet at 3 o'clock the normal time, not Monday, Tuesday, sorry. I was not able to meet at the normal time, but I did hold a lesson and I put it on my YouTube website. So if you haven't seen the Tuesday lab, it is up on the YouTube website. And I know a number of you showed up for the 7 p.m. Um, lab, and that's great too. Any questions about any of that?
I have a question about the this quiz yesterday.
Uh-huh.
I had issues accessing the lockdown browser, and I think a lot of other people did as well.
Yes, I know what the problem was. I'm surprised you were even able to access the lockdown browser and the quiz. The problem was is that Clark College's network was down. And so you could have done it like after 7 p.m., but before 7 p.m., Clark College's network was down. I have extended the time of the quiz, so you will have until 11:59 p.m. tonight.
Sounds good. Thank you.
Okay, any question about any of that? Come on. Oh, right. All right, if there's no questions, let's move on. Am I sharing my screen now? Anyone?
Yeah, you are.
Yes.
All right, let's go to the lesson. So today is January 18th, and we're supposed to be discussing Lab 2, aseptic transfers. Now earlier on Tuesday, I did discuss, and we have began, come on. Sorry, my mouse has got this blocking the way here, and I don't know how to remove that. There we go. We did discuss the infectious disease project, and that project has begun. You need to watch the video on that if you haven't, and then choose what infectious disease project you want to do, and then send it in to me to get an okay. So far, most students, I have now had to narrow the project. So most students, I've told them, no, it's too broad. I want you to narrow it in on such and such. And one example is somebody asked for pneumonia, and I said, no, there's too many causes of pneumonia. Pick one agent that causes pneumonia, and then you can do the project on that. And then there's like the flu. I'm breaking it down in influenza A, influenza B, influenza C. And like I said, if you watch the video, you'll find more information about that. But that project has begun, and the first person to request a topic will get it. Later, people, if it's the same topic, I'll tell you, no, that topic has already been chosen. Any question about any of that? All right, if not, let's begin Lab 2, aseptic transfers. Let me scroll that to the top. Come on. I don't know why I can't move that to the top.
Excuse me, sir.
Yeah.
For
there-
this project, are you wanting us to actually email it to you, or do you want us to message it to you on Canvas?
That's a message on Canvas. I prefer the Canvas email. If you send it to my clark.edu email, I will only check that email at most twice a week.
Okay, thanks, sir.
And when I say email, I actually mean the Canvas email. All right, let's go to lab module. Lab module 2, aseptic transfers. The learning objectives are, first thing I'm going to talk about, be able to understand the purpose of using aseptic transfer techniques, determine if aseptic transfer was used from the data provided, meaning we'll give you a picture and then you tell us whether aseptic transfer was used or not. And then define the following terms: ubiquitous, aseptic transfer, inoculation, and contaminant. Any questions about that? All right. In our local environment, microorganisms are ubiquitous, meaning that they are almost everywhere. This is problematic when working in the microbiology lab because we generally want to work with a pure culture, a culture that contains one and only one species. Louis Pasteur developed how to get a pure culture, as well as making aseptic transfers to minimize the risk of culture contamination. We're going to learn how to make aseptic transfers in this lab. During inoculation, when you add cells to a sterile culture media, never lay the cap. I don't have a test tube, but this will be representing it. Never lay it on the workbench. Never put it on the workbench upside down, because either way, microorganisms from the air can fall down into the cap. And then when you put the cap over the tube, the microorganisms can fall from the cap into the tube. And even on the workbench, there's microorganisms on the workbench. You can take the cap, and you can't see this, but they'll pick up the microorganisms on the edge of the cap. And then when you're bringing the cap over the open container, the microorganisms may fall down into your open container, contaminating the tube. To minimize contamination, tilt the nutrient auger tubes at an angle. The reason being is if you do, if something falls down from the air, it won't come into the open space. There's less open space when you have this at an angle. Anything coming down will come down. Now, anything coming down will not get inside unless it happens to come directly in this region right there. With the Petri plates, and this was actually something that was covered in a previous lab, you want to never take the lid and put it on the counter. And actually, when you're opening the plate and then inoculating the plate, you want to use the lid to help protect the plate so that if anything comes falling down from the air, it'll hit the top of the lid, not go into the plate. The only time it would go in the plate is if it comes down right here. Any question about any of that? In order to inoculate, that's transfer cells into new sterile media, we must make sure that we sterilize everything that can potentially contaminate the sterile media. And how we do that is, of course, we use sterile media. We have the tube of the culture, which is sterile except for the one species inside it. And then you take the caps off and sterilize the tool that you take the cells out of this tube to move them into that tube. How you sterilize the tool, this would be one tool, the loop, is you take the wire portion of the loop, meaning this portion here, and pass it either through a Bunsen burner or into a bacto incinerator until the wire portion turns red hot. And then it's cooled before you pick up the cells and then transfer the cells into the new media. All right, so know the terms of this lab. And when we're doing this laboratory exercise, you will not be physically performing any of these activities because all we're going to do is work with it online. But you will be watching videos of these activities, and we expect you to know and understand the material in these videos and in this lab. In procedure 1, you're going to be transferring a sterile liquid using a glass serological pipette. In procedure 2, you're going to be transferring a sterile paper disc into a tube using clean forceps. So please watch the video demonstrating proper aseptic transfer when you're working on the lab. Just click on this link here. In procedure 1, as I stated, you're going to transfer 1 ml of sterile water using a glass pipette into a nutrient broth, meaning into a tube of nutrient broth. Now, when you're measuring liquids, especially liquid water or something based on water, in a glass container, like a pipette or even a birette, you'll notice that the liquid does not go across the glass smoothly and flatly. It comes and forms a meniscus where it's higher at the edge than it is in the lowest part of the meniscus or the center of the meniscus, whatever you want to say. And where you read the meniscus is at the bottom of the meniscus, not in the middle of the meniscus, and not at the top of the meniscus. Any question about any of that? So you transfer 1 ml of sterile water into the liquid broth, and this is the media that we're going to transfer the sterile water in. You should note the picture here and note whether it is transparent or translucent or what's the word? Cloudy looking. When you're growing, we'll talk about that later. Never mind.
I'm not sure we're seeing your screen.
You're not seeing my screen?
I think I'm just seeing the lecture topics and exams.
Yeah, same.
Oh, geez. Your screen sharing is paused. Why is that? Let me stop the share and restart it. I'm not sure what happened. I didn't even know you could pause the screen sharing. Are you seeing my screen now?
Yeah.
Yeah.
All right. When did that start? I was trying to show you a whole bunch of stuff.
We never saw anything.
All right, you guys need to give me a heads up on that earlier. I had the screen sharing on, but for some reason it was paused. I didn't even know you could pause it. Geez, I can't believe nobody noticed that. I was telling you, you don't put the cap down on the workbench. And then I was showing you that with your Petri dish, you hold the Petri dish at an angle. I don't know if you can see the dish here. with the lid off. And then you streak it where the lid is partway over the dish, and that protects the dish, because when bacteria fall down from the air, oh fudge, oh, here it is. Most of the bacteria will be falling on the top of the dish, and that's fine. You only have to worry then about stuff falling into the dish right there. I told you a whole bunch of things, and I thought you were seeing my picture. Okay, so you need to let me know when you're not seeing the picture, especially when it told me that I was sharing my screen. Okay. I don't even see an option for pausing. So I'm not even sure what happened. All right, let's continue. I showed you what a pipette looks like, and you have to stick it in the flame or the back to incinerator until it's red hot. There's the link for watching proper aseptic transfer. There's your media there before you use it. All right, so in this lab, you need to use this table. And for procedure 1, in this table, for the result, if the nutrient broth is clear, the conclusion is there are no organisms growing in the broth, and aseptic transfer was successful. If, on the other hand, the nutrient broth is hazy, cloudy, or turbid, then organisms are growing in the broth and aseptic transfer was unsuccessful. Any question about any of that? Let's go down to procedure 1. There is the tube that you inoculated with 1 ml of sterile water, and then we incubated it overnight at 35 degrees Celsius and took it out, and you can see the tube here. And then you come down here, yours will be 0, question 0. Describe the initial clarity of the nutrient broth prior to inoculating, adding the sterile water or the paper disc. You need to state, was it clear or turbid? And there it is there. And then question 1 for procedure 1, that's what P1 stands for. Describe the clarity of the nutrient broth after inoculating with sterile water and overnight incubation at 35 degrees C. Was it clear or turbid? And there is procedure 1's tube. Any question about that? And then answer 1B, based on these results, what conclusion can be drawn? And your wording has to be similar to the wording in the table. If it's not similar, I'll just mark it wrong. Okay, so the wording has to talk about whether there are organisms growing in the broth or not, and whether the aseptic transfer was successful or not. And then 1C lists 3 sources of error with aseptic transfer that could explain why the nutrient broth showed growth of microbes. So come up with 3 sources of error. Any question about procedure 1? If not, let's go to procedure 2. You're transferring sterile paper disc using clean forceps. The paper disc is sterile. The forceps are not sterile. because if you were to stick the forceps, let's pretend these are forceps. I might actually have some here someplace, but I'm not sure where they are. And if you were to put that in the back to incinerator until they became red hot, the heat would move up the metal of the forceps, so you could no longer hold the forceps with your hands. So you cannot sterilize the forceps, but you can clean them, meaning you can put the forceps in the back to incinerator briefly, so the very tip of them become hot, but not red hot. And then you can put the forceps in alcohol and then take the alcohol to the back to incinerator to light the alcohol. And then that will burn the alcohol in the forceps. That cleans the forceps so that they are good enough to use. And then you open up the Petri dish containing the paper sterile disc, and using the forceps, I'm just going to use my fingers. Take out the paper disc, pretend this is paper disc, and then put it into the tube. Any question about any of that? And there's the media putting the paper disc in. Use this table for getting your results and your conclusions, and the wording must be similar to the wording in this table. That is the tube for procedure 2. And there you can actually see the paper disc at the bottom of the tube. And then answer the questions for question 2. Describe the clarity of the nutrient broth after inoculating with a sterile paper disc and overnight incubation at 35 degrees Celsius. Was it clear or turbid? And then based on these results, what conclusion can be drawn? Any question about any of that? All right, for procedures 3 and 4, you're going to be transferring Serratia marsans to a broth for procedure 3. For procedure 4, you're going to be transferring Serratia marsans to an agar slant. We have a little video demonstrating how to correctly transfer from a bacterial stock culture to a sterile broth and to a sterile slant. So watch that little video. You only need to watch the video to 4 minutes and 23 seconds. You'll note that E. coli is used in the video. We're using Serratia marsans. E. coli is a non-pigmented bacteria. Serratia marsans is pigmented. The methods used are the same. There is an error made when the instructor puts the loop into the E. coli. The error, you can hear it between 3 minutes and 5 seconds and 3 minutes and 20 seconds. You'll hear sizzling when he puts the loop into the E. coli, and you should try and figure out what that error was. All right, when you use aseptic transfer to transfer Serratia marsans to a sterile broth, Serratia marsans is red pigmented when it's grown on a solid media. When it grows in a liquid media, it will be pink in color. However, when you grow cultures in a broth culture, all of the cells will mix together. So that is a problem, because if contamination occurs, if it's minor contamination, you may most likely not be able to notice it. You would only notice it if it is major contamination, where the contamination is more cells than the cells you're trying to grow. Any question about any of that? All right.
Can you explain a little bit more about what you mean by that? How did,
You
yeah, how did,
inoculate a liquid culture, a broth, with the cells. And if there's minor contamination in there, let's say Serratia marsans will look pink in this tube, E. coli would look off-white. You won't notice the off-white color because all the cells mix together. It'll look pink because Serratia marsans is the major cells in the tube. Any question about that? The only way you would notice it is if E. coli was the main cell in the tube, then the pink color would be very light, very slight, or would not exist at all. And then you could say, oops, that's not right. That must be a contaminant that grew. All right, for procedure 3, you use this table result. If nutrient broth is clear, then no organisms are growing in the broth, and aseptic transfer was unsuccessful. Why is aseptic transfer unsuccessful if the nutrient broth is clear? Think about that. All right. Think about that if you don't know the answer. Hopefully, most of you are just too shy. Here is the results of procedure 3. The tube for procedure 3. Come down to the questions. Describe the clarity of the nutrient broth after inoculating with Serratia marsans and overnight incubation at 30 degrees Celsius. Was the tube clear or turbid? Based on these results, what conclusion can be drawn? And remember, you must use the table or wording similar to the table for your conclusion. And then how do you know whether you've transferred the correct microbe, Serratia marsans or not? Anyone?
Broth will be pink.
Yeah, the broth looks pink, so it looks like everything's okay. At least the majority of the cells are Serratia marsans. We don't know about the minority though, because this is a broth culture. All right, let's go on to procedure 4, where you transfer Serratia marsans to a sterile agar slant. Contamination can be more easily determined because when you're transferring, there's a slant. When you're transferring the bacteria, you use a loop and you'll put it in a streak, something like that, meaning usually when you do a slant, you do it in an S-type movement. And if you see like white growth right here, or even white growth in this region where the streak is, it tells you that's contaminant. Or I should say not white growth, but any growth that's other than red, because it should be all red because this is grown on a solid media. And then you use this table for making your conclusions. If the slant does not show confluent or colony growth, then no organisms are growing on the slant and aseptic transfer was unsuccessful. If the slant does show confluent or colony growth, organisms are growing on the slant and aseptic transfer was successful. There's the tube for procedure 4, and there's so much growth you don't see the streak, but the streak happened in this central region of the slant. I mean, you can see the agar right there has nothing growing on it in this portion right there. And it looks like there's no area that's not reddish. So it looks like there's no contaminant there. And then come down and answer the questions. Is there bacterial growth on the slant? Yes or no? How do you know? Just answer that. And does it appear to be the bacterium you inoculated or a contaminant? Any questions about this lab? Okay, I will be here until about 4 o'clock to help you and answer any questions. Let me state that I have graded labs, the first grading of lab 0 and lab 1, and some of you could have used my help, meaning some of you missed a lot, and you will get an opportunity. You have until 11:59 p.m. on Saturday to turn in the lab 0 and lab 01 a second time for 100 points. So I'm here to help you. That's why I stay in the lab after I'm done talking. All right, are there any questions? If not, I'm going to stop sharing until you get started on the lab. You may log off. If you do log off, you should not be working with other students. You should make sure all your work is in your own words. You can work with other students, but all your work must be your own work.
Thank you.
Right.
Thank you.
And I will log off once the last student has logged off, which I will be here at least until 4 o'clock. Let me word that. I will be here until the last student logs off or until 4 o'clock.